Hi dear students, good morning. Today we have to discuss the remaining topics of the acid, bases and salts. The next concept is acids with carbonates and bicarbonates. These also same lab activities. Yes, two lab activities also we have to perform as usual. Just we have to replace the carbonates with bicarbonates. Remaining experimental procedure will be the same. Yes, for this experimental procedure we have to require the one stand. What we have to take? First we have to take the stand. This stand we have to fix with the test tube. Okay, first test tube we fix to our stand. Again, now we have to close this test tube with rubber cork. Which cork? Rubber cork. Okay, to this rubber cork we have to insert the crystal funnel into the test tube. Okay, to pour the some amount of the chemicals what we require in this laboratory. Okay, again one we have to insert the delivery tube through the rubber cork into the test tube. Okay, again one side of this delivery tube should be connecting into the another test tube which it is contain calcium hydroxide solution. What it is there? Calcium hydroxide solution is there here. Calcium hydroxide solution only here. Okay, that we connected to here. Okay, through this crystal funnel now we have to pour the some amount of the dilute hydrochloric acid. Dilute hydrochloric acid we have to pour through this crystal funnel. Again we have to add the some amount of the carbonates. First activity is what? With carbonates. Now sodium carbonate Na2CO3 solution we have to pour into this test tube. This is what? Hydrochloric acid. Dilute hydrochloric acid. To this what we added? Na2CO3 solution we added to this. Now what will be happen? When we add that hydrochloric acid to the carbonates, what will be happen? What kind of the reaction will be happen? Which kind of the compounds will be formed? Just we have to identify by this lab activity. Before that, just we have to check by the reaction. Here hydrochloric acid HCl is reacting with sodium carbonate Na2CO3. Sodium carbonate we have to take. To this sodium carbonate with hydrochloric acid, which kind of the products will be formed? Here sodium is there, here chlorine is there, sodium chloride will be formed. What will be formed? Sodium chloride will be formed, and along with this carbon dioxide gas is releasing. Which gas is releasing when the acids are reacting with carbonates? Carbon dioxide gas is releasing, and some amount of the water also releasing. Some amount of the water also releasing. Suppose just we have to take another example of our king of chemical, sulfuric acid H2SO4. It is also reacting with Na2CO3, again also forming that same compound, sodium chloride, again carbon dioxide, again some amount of the water also releasing. That's mean by this reaction we are concluding that when the acids are reacting with carbonates, the formation of the compound is one kind of the salt. This is then the carbon dioxide gas, again some amount of the water molecule is releasing. Yes, we have to prove by the experimentally. We have to prove by the experimentally. Okay, the carbon dioxide gas is releasing. It is passing through the delivery tube into the another test tube. Okay, in the another test tube there is a calcium hydroxide solution is there. This calcium hydroxide solution is reacting with carbon dioxide. What will be formed? Calcium carbonate will be formed. This is a white color precipitate. What is this? White color precipitate will be formed by the formation of the white color precipitate is here. We are concluding that what? Releasing gas is carbon dioxide. When the second test tube into the solution is becoming into the white color like the precipitate, we have to conclude that the released gas is what? Carbon dioxide. Yes, when the calcium hydroxide is reacting with the carbon dioxide, it is formation of the calcium carbonate and some amount of the water molecules also forming. Some amount of the what will be formed? Water molecule also forming. Suppose to this calcium carbonate white precipitate, if I add some amount of the carbon dioxide to this calcium carbonate with water, if I add some more amount of the carbon dioxide, what will be forming? It's undergoing the chemical reaction and forming the calcium bicarbonate. What will be formed? Calcium bicarbonate will be forming. When we add excess amount of the carbon dioxide to this white precipitate, what will be formed? Calcium bicarbonate will be forming. What will be forming? Calcium bicarbonate will be forming. Everyone should remember the formulas. Yes, everyone, you should be remember the formulas. Once more, I am concluding this activity. When the acids are reacting with the carbonates, what will be forming? Some amount of the salt along with carbon dioxide and some amount of the water will be forming. Yes. Suppose in the place of this here sodium carbonate, if I take that sodium bicarbonate NaHCO3 bicarbonates, if we take the bicarbonates, what will be forming? Yes, in the place of the Na2CO3, same experimental procedure, there is no change, just I am taking the sodium bicarbonate NaHCO3. Yes, suppose just I am writing the reaction is here, hydrochloric acid with sodium bicarbonate NaHCO3. What kind of the products will be forming? NaCl, carbon dioxide, again water molecule. Again what will be forming? Water molecule, carbon dioxide, sodium chloride. Here you have to see the same compounds. Here also the same compounds will be forming. That means what we are finalizing when the acids are reacting with carbonates and bicarbonates. Acids are reacting with carbonates and bicarbonates. In the two situations also the releasing gas is carbon dioxide. In the two situations also the releasing gas is carbon dioxide and some amount of the salt and water also forming. In the examination they can ask the direct question, which kind of the gas is releasing when the acids are reacting with carbonates and bicarbonates. Simply what we have to tell, carbon dioxide gas is releasing when the acids are reacting with carbonates and bicarbonates. Okay, next concept of pH. Negative logarithm of hydrogen ion concentration is called pH. Negative logarithm of hydrogen ion concentration is called pH. pH that is equal to minus log H plus. pH that is equal to what? Minus log H plus. Okay, pH. Yes, negative logarithm of hydrogen ion concentration is known as a pH. Okay, pH that is equal to minus log H plus. Here P mean power, that means potent, some kind of energy, power, potent. Okay, the pH values we already know, it is starting from pH values are 0 to 14. 0 to 14. This is then a pH scale to measure the pH values of the given samples. Maybe the acids, maybe the base, maybe the salts. The pH scales discovered by the Sorensen. Who? Sorensen discovered the pH scale. There is a chance to ask in the examination in the choose the correct answers. Sorensen discovered the pH scale. Who discovered? Sorensen. Okay, the pH values are starting from 0 to 14. Suppose pH 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 and 14. Okay, here pH 0 to 6 is acids. We already know. pH 8 to 14 is bases. Okay, exactly at 7 it is in salts. Exactly 7 it is in salts. Suppose what I am asking, pH 1 and pH 6, which is strong acid? pH 1 is strong acid, pH 6 is strong acid. 100% pH 1 is in a strong acid, it is in a weak acid. While we move from left to right 0 to 6, acidic strength will be decreasing. What will be decreasing? Acidic strength will be decreasing. Suppose pH 9 and pH 13, which is strong? pH 13 is strong because while we move from 8 to 14, the basic strength will be increasing. Basic strength will be increasing. Here acidic strength will be decreasing. By this we are concluding that what? Acids are dividing into the two categories, strong acids and weak acids. Bases also dividing into the two categories. What is that? Strong bases and weak bases. Strong acids, strong bases. Weak acids, weak bases. Suppose strong acids: hydrochloric acid, nitric acid, H2SO4, sulfuric acid. These three are the strong acids. You have to remember: hydrochloric acid HCl, nitric acid HNO3, sulfuric acid H2SO4. These three also strong acids. Next, weak acids: H2CO3 carbonic acid, H2CO3 carbonic acid, H3PO4 phosphoric acid, carbonic acid, phosphoric acid, CH3COOH acetic acid, carbonic acid, phosphoric acid, acetic acid. These three also the example for the weak acids. These are the example for the strong acids. Next, strong bases. What are the strong bases? Suppose sodium hydroxide, potassium hydroxide. These are the strong bases. Okay, weak bases. Ammonium hydroxide, NH4OH, ammonium hydroxide. Next, magnesium hydroxide, calcium hydroxide. These are the weak bases. These are the which bases? Weak bases. Once more I will repeat the examples of the acids and bases: hydrochloric acid, nitric acid, sulfuric acid. These are the strong acids. Carbonic acid, phosphoric acid, acetic acid. These are the weak acids. Sodium hydroxide, potassium hydroxide are the strong bases. Weak bases: ammonium hydroxide, magnesium hydroxide and calcium hydroxides are the weak bases. That's mean we got that strong acids, weak acids, strong bases, weak bases. Now in the next class we have to discuss about the neutralization reactions in between of the strong acids with strong base and weak base, in between of the weak acids with strong bases and weak bases. That's mean these four types of the acid bases reactions we have to discuss in the next class. Okay, thank you so much. Jai Hind.